Okay, 10-2. We're going to talk about angles within a circle. Know that today is the easier kind. We're also going to be looking at angles that are inside and outside the circle that are a little bit harder than today. So today's the easier one. Central angle is an angle that has the vertex in the center of the circle. If you look at my example, angle ACB, C is the center of the circle. This is considered a central angle. Because it's a central angle, this angle, ACB, and this arc are going to be exactly the same. So if this central angle is 60 degrees, then this arc AB is going to be 60 degrees. So they match. That's the easy one. The other ones are going to be a little bit more complicated. So again, a central angle has the vertex as the center of the circle. An arc is part of the circumference. So when I talked about arc AB just a minute ago, this line or this arch, I guess is the way I can say it the best, is part of the circumference. Remember, circumference is like a perimeter. So if I'm talking about the perimeter of a circle, I'm talking about how long that line is. And when I'm using line loosely, but how long this arc is. It could be 4.2 inches. It could be 8 meters. This arc, AB, could be something like 5 inches. That's what I'm talking about. So you have to also see that there's two different ideas here. When I'm talking about an arc, I could be talking about the measurement of the arc in degrees, like what I was talking about a minute ago. And when I'm talking about degrees, it's saying the measurement of. So when it says the measurement of AC, I'm looking for degrees. So it's important that you see what those notations mean. So are we looking for something like 5 degrees or 27 degrees, 310 degrees? Or are we looking for a distance like 5 meters or 8 inches? This is asking about distance, like part of a circumference. This is asking for degrees. So this is going to be somewhere between 0 and 360 because we know a circle is 360 degrees. So the measurement of an arc is between 0 and 360 degrees, whereas the distance of that arc is going to be something like inches, miles, meters, centimeters, whatever. There's minor arcs, major arcs, and semicircles. Minor arcs have a central angle of less than 180, and it's notated with just the endpoints. So a good example of this one is from A to B. That's a minor arc because this central angle is less than 180. Remember, 180 is the diameter. It's also a straight line. A major arc has a central angle greater than 180, and it's named with the endpoints and another point on the circle. So the example I used was ADB. You kind of want to use your fingers so you can figure out which way you're going. From A to D to B, this is the arc that we're talking about. If I just said arc AB without that rule of knowing which way to go, we wouldn't be sure if it was this arc or if it was this arc. So those 3 letters is your tip off as to what direction to go and what arc we're talking about. The other thing I want to point out, I said ADB, that would be this arc that I have kind of double lined in black. This is a separate arc of ABD. So that's why I'm saying use your finger to kind of trace where you're going. ABD is definitely a different arc and could also have a different central angle measure. A semicircle, it has a central angle of 180 degrees and it is named with 3 letters. So a semicircle isn't a minor or a major because it's exactly 180 degrees. And it's named with 3 letters. So if you know a diameter, if you know that that's the diameter, we know that this arc, FED, is going to be 180 degrees. Central angle is 180, which means that that arc is going to be 180. These 2 ideas we're going to use in some of our examples. Congruent arcs have the same measure. That should make sense. Congruent arcs in different circles have the same radii. Remember, we talked about this in 10-1, where the only thing that can be different with circles because they have the same shape is the radius. That's the only thing that can change. So if the radii are the same, then those arcs are going to be the same. Let's look at naming some arcs here. So we need to decide, is it a major arc, a minor arc, or a semicircle? First one is TQ. So we're looking at this arc from here to here. What's the measurement of, or what is that? What's the degrees for T to Q? Ella? Exactly. So this central angle is 120. So this angle, or this arc, is 120. And is it major, minor, or semi? It's minor, it's less than 100, 180. QRT. Starting here and we're going all the way around. How do we figure out that measurement?
It's 120 and you're 80.
Good job. So it does appear, if you're not sure, ask me, but this is actually the same example as in your book on page 660. This is two diameters that are crossed. So because this one is 120, this one's also 120. So we want to add up these three central angles, 60, 120, and 80, which would give me this arc. And what was that total again?
260.
260.
Yep. Major, minor, or semi? It's major. The next one, TQR. We're going in this direction now. T, Q, and R. What's the measurement of that arc? Yes?
180.
Good. We can add these two central angles up. TQR is 180. Is that major, minor, or semi?
Semi.
Good. How about QS? From Q to S. What's the measurement of that one?
180. Oh, yeah.
And that one should have a middle letter there. That should be QRS because it's 180. Because that's what we had just talked about over here with semicircles. So this one's a semi, it's 180. How about TS? This one right here. It's a measurement of RTS.
80.
Yep. And is it major, minor, or semi?
Minor.
It's minor because it's less than 180. And RST. That's from here all the way around to here. So what's the measurement of that one?
200.
RST? Yeah, you're right. 200 degrees, major, minor, or semi?
Major.
Good job. So I want you to be able to recognize major, minor, semi, and be able to figure out what the arc measurements are when you're given the central angles or vice versa. Moving on to more examples. So you're given that arc PQ, this arc here, is 90 degrees. And you're asked to find the distance. Remember, this is a segment. Be careful with your notation. From P to Q, you're trying to find the length of that line. So what do you see that's going to help you figure that out? What do you see? Good. Good. That's a good start. This is a right triangle. Well, how do you know it's a right triangle?
Because the points align.
You're right. I just want to know why. Why?
Because the arc is 90 degrees.
There you go. This is what we're learning today. So this is my central angle. The central angle and that arc match. So if that's 90, this has to be 90. Okay, so now we're trying to find the length of that PQ. How do we do it? How do you know that this is 7?
Because all the radiuses.
This is the center of your circle. R to P is labeled as 7. R to Q is also a radius. No matter where you are in the circle, if you start at the center and end somewhere on the circle, it's always going to be a radius. They're going to be the same within the same circle. So if this is 7, this is also 7. So we could do the Pythagorean theorem, but we have a shortcut that we learned. Who said it? Yes, explain.
They're both the same length, so it's 45, 90.
Mm-hmm.
And so the hypotenuse is square root.
She's got us almost there, guys. So she said, yes. Recognize this as a 45, 45, 90. Remember, we have a right triangle. These two legs are the same, which means these two angles are the same, which means we're allowed to use that 45, 45, 90 rule. Nothing wrong with using Pythagorean theorem, but that rule is going to be super quick. that rule says, and I think she said this a minute ago, the leg times the square root of 2 gives you the hypotenuse. Look how easy this is, guys. If you know that rule, the answer is just 7 square root of 2. Again, there's nothing wrong with doing the Pythagorean theorem, but if you remember this rule, this is super quick. If you did the Pythagorean theorem, you might get a decimal answer, and I believe you would. But there's nothing wrong with that answer because it doesn't specifically tell you how to do it up here. Okay? How about this one? We're asked to find the measurement of LKJ. So we're looking for this arc here. These markings in the center show that they're congruent. I just want to make sure you guys see that when they draw pictures in the book, a lot of times it might look like they're overlapping. So instead of showing that they're right in line like this, they look like the same arc. So what they'll do is they'll kind of stagger them. But those markings, because it has one arc, that means that they're the same. So I want you to see that on here. These two central measures are the same. So if these two are the same, how do we go about figuring out the measurement of that arc? We have to figure out this angle of JGK. What would we do?
360 minus 74 divided by 2.
So we know these three angles have to add up to 360. So 360 minus 74 divided by 2, what's this angle? Someone do that for me, please. 144. So if this is 74, this is 144, those are my central angles. What's the measurement of that arc? What do I get?
224.
228. Okay, moving on. Over here, we're asked to find x. Remember, these are all central angles, so the central angles will match that arc. What do you see that might be helpful with this problem? Any wild guesses? I would start by labeling everything. Go ahead.
Are the arcs of the opposite section of the circle congruent?
Uh-huh.
Like 80 on the other side.
Yep. So if you think this is 80, the central angle would be 80, which means the vertical angle would be 80. Central angle and the arc match, that's all 80. We're trying to figure out what x is. So the same idea. If this is x, this is x. If this is 57, this central angle is 57. So this one's also 57. We can look at a semicircle, right? So if we look at this semicircle here, we have 80, 57, and x. Take 180 and subtract that 80 and 57. What do we have left for our x? If you want to make an equation out of it, you can say 80 plus 57 plus x equals 180. So what's x?
43.
So this little angle is 43 degrees. The last one, this one's a little bit tricky. This is what we talked about a minute ago with those two stars over there on the other board. We want to figure out if arc AB and arc CD are congruent. From here to here and from here to here. Be careful with this. So when you're looking at this, you want to think about, let me show you an extreme example. So if I had a little circle this big, and the central angle is 46. I know that this measurement is also 46, right? That's what we talked about today. However, if I had a bigger circle that also had an arc, this arc is 46 degrees, and this angle is 46 degrees. Just because that central angle and the arc measurement matches, does that mean that this length right here and this length right here will be the same? Absolutely not. It's not going to be the same. Just visually look at it. This little yellow arc and this yellow arc is not going to be the same. If I said this one was, I don't know, 6 centimeters, that one is definitely not 6 centimeters. So they don't match. What's going to make them match is if I can prove that my radius are the same, then that means that those arcs are gonna be the same. So if the radius is the same and the central angle is the same, that guarantees that that arc's gonna be the same. So that's what you have to look at with these examples here. So I see that my central angle is the same. These arcs are both gonna be 46 degrees, but can I verify that my radius is the same so that I can say that those two arcs are the same? Yes or no?
Yes.
You can. So look at the blue circle first. This is a radius that starts here and ends here. Same with the A one. So both of those have a radius. Same thing over here with the pink circle. This is a radius, this is a radius. Well, look at the blue circle. If I take it the center and I draw my radius starting at the center and ending some point on the circle, that black line is a radius of the blue circle. Look at the pink circle. I'm starting at the center and ending on the circle. It's the same radius. So because they have the same radius, that verifies that A, B, and C, D are going to have the same length. If you didn't see it before, do you see it now? Okay, what about this one? They have the same central angle, but that's not enough to say that those two angles or those two arcs are the same measure. And this is a good example here. Just because they have the same central angle, that's not enough. You have to verify that the radii are the same. So do both of these circles have the same radius? Same length of a radius?
No,
Explain.
I mean, I just kind of say, I can just like kind of see by looking at it.
You can, but you can also kind of draw some pictures on here. So this radius is drawn from here to here, this black dotted line. There's no way to verify that black dotted line, and let's use a different color. And this pink dotted line is gonna be the same. Now these are hand drawn, but again, there's no way to verify it. This we could easily verify it. This one we cannot. So this one we can say that it is not congruent because we don't know enough, or it's just not congruent. Does that make sense? Okay. No, that's okay.